In this video, we'll be going over two different in-place reverse string algorithms, one which uses a hold character and another one that uses a swap command. We'll be going over the functions implementations in C++ and in Python, including unit test, where C++ here is using Google Test and Python is using PyTest. We'll also go over how to compile and run the C++ version with CMake or with the standalone scripts and how to also run in Python. You can find all this code and instructions on how to use it in the Algo's GitHub repository, and I'll leave in a description. And this is also where you can find the Astrodynamics with Python repository for those who are interested. So to get started, we have a C++ implementation of the in-place reverse string function, and on the bottom is a Python version. The input to the function is going to be an array of characters. In this case, we'll be using the word Astrodynamics, and we can think of this array as the diagram on the top where each character is sitting in its block of memory. And these characters don't necessarily have to be contiguous in memory, but we'll assume they are here. And note that the input here is a reference to a character vector. So we are going to change the values within the array, so we aren't returning anything, so we mark this function as void. Same for Python, the input is a list of characters, not an actual string, and since Python passes arguments as references to objects, and Python lists are mutable, we can think of this list as being passed by reference, so again, we won't be returning a new list, we are just modifying the one passed in place. For this implementation, we start by defining a character variable which is stored in the stack named hold that we'll be using to temporarily store values. And then we define two integer indices that we'll be using to point to characters within the array. And for Python, we don't actually need to define the hold variable up here, but I kept it in there to better compare between the two languages. And since both C++ and Python use index 0 as a first value, we subtract 1 to the IDX1 variables. And now we start with a while loop where initially 0 here is less than 13, which evaluates to true. And the first thing that we do is move the character that is currently sitting at IDX 0 place and move that into hold. And this will actually just copy that value into hold, but for intuition, we can think of it as moving it over there. And now that we have that value stored somewhere else, which is in hold, we move the value that is sitting at IDX1 and place it into the IDX 0 place. And this is why we needed to store the IDX 0 value somewhere else, since this step overrides the IDX 0 place in memory. We then move what is currently stored in the hold variable and move that into the IDX1 place, and that completes the switching of the first and last characters of the string. And now, in order to not get stuck in an infinite loop, we increment IDX 0 by 1 and decrement IDX 1 by 1, so they move inward in the array. And then we repeat this process until IDX 0 is less than IDX 1 evaluates to false. And this will happen for odd lengths of strings when they meet in the middle, where in this case they would meet at y, which is index 6, and 6 less than 6 is false. And for even strings, they'll cross over each other, which will also trigger to get out of the while loop. Now here, you might be thinking that instead of using this extra hold spot in memory, there's probably some command to swap two values in memory, and you'd be right. In C++, we can use the standard library swap function to do just that, which simplifies the algorithm and function on our side by 2 steps. And for Python, here's one implementation of swapping two values. And note that for both, we don't need that hold variable anymore, which saves us memory. But what we're actually doing by switching to the swap function is abstracting that away to the standard library, but in reality, it's doing something similar as the previous implementation. Here's a good answer on Stack Overflow to the question on the C++ library standard for the swap function. And the implementation of creating a temporary copy of one of the variables, then overriding the first with the second with a temp variable, is an old implementation in the C++ standard, but has since been updated to use the standard move function. So here's documentation on that swap function. And here's another good answer going over the move function in C++. So these specific implementations are outside the scope of this video, but I'll have links to these sources if you're interested in learning more of these details. Now going to LeetCode, here we have that same C++ implementation with an extra check to see if the array is just one character, get out of the function. And of course, there are many other specific implementations. So if we take a look at the fastest one here, that just uses a standard library reverse function, and there's many other implementations. But hopefully the ones that I showed in this video will help you more intuitively understand how to go about solving this problem. If you'd like to experiment with the scripts, here we'll go over how to run them real quick. So for Python, you can simply just run the test script like this, going Python 3 src py reverse string test.py, and it'll just print out Astrodynamics and Astrodynamics backwards as is shown here. And for the C++, you can either build the repo with CMake or just run the script standalone. So we can start with standalone. So if we just say src cpp standalone reverse string run.sh, it's going to do exactly the same thing. It's just this script right here, just building it like that. And if we go to that to that bash script, we can just take a look at it real quick. What it's doing is just using a path algos, which is an environment variable that points to the src directory of this repository, and then just using G++ to compile it, run it, and then delete the executable. And if you like to run it with CMake and you have to build it with CMake and then test, we can go cd build, where initially you'll have to say make.dir build. And then if we go CMake src like this, obviously everything's already done because I've already done this, make-j4 just to use parallel threads, and then ctest like that. And then all these instructions of how to build this with CMake and run the standalone functions are in the GitHub repository README. The next video in this series will be an introduction to recursion using the factorial function. So LeetCode has the next topic as intro to recursion using the swap nodes pair functions. So I'm going to go out of order since I think that learning recursion is going to be a lot more intuitive using factorials, since it's a math function that we all know and fundamentally actually has recursion properties. Since, for example, 5 factorial equals 5 times 4 factorial, which is also equals 5 times 4 times 3 factorial, and so on. So be sure to hit like and subscribe to stay up to date with this series, the Astrodynamics with Python series, Rocket Trajectory series, and the Space Engineering podcast, all of which can be found on this channel.